Okay, let us do the problem 5.16. Draw the diagram first and then we will discuss. So you draw the diagram up to here and then slowly we'll go down. So draw this diagram and then we'll go. So what the problem says we'll discuss. So first draw the diagram. So I will be giving you 2 minutes for drawing the diagram. Okay, let me read the question. 5.17, a light beam falls upon a plain parallel glass plate. No, this is the 5.16. Okay, so I have to read 5.16. So this problem says 5.16, two optical media have a plane boundary between them. Suppose, so there are two media. This is medium 1, this is medium 2. There is a boundary between these two medium. Now, suppose theta critical is the critical angle of incidence of beam and theta 1 is the angle of incidence at which the reflected beam is perpendicular to the reflected one, and the refractive index of medium 2 is eta. So this refractive index is not given. Find the refractive index of these medias. So find the refractive index of medium if sin theta critical divided by sin theta 1 is eta. Okay, let us see what this question says. This question says in the first part, a light rays come and this goes something like this. This means this is a critical angle at which this light rays goes at a 90 degree from the normal. So you see this theta critical is given. N1 is the refractive index of medium 1 and N2 is the refractive index of medium 2. Now in the second part question says there is another incident ray comes at angle theta 1 and this ray basically diverges into two parts. One ray goes reflect back and another transmits, that gets refracted. And question says reflected ray and refracted ray makes an angle 90 degree. Theta 1 is given, 90 degrees is given, theta critical is given, and we have also given one more thing, theta critical by sin theta 1, that is equals to eta. So sin theta critical come from this, so this is from experiment 1 divided by sin theta 1, so this is given, this is equals to eta. Now we have to find what is the n1 by n2. This is the thing that we have to find. So let us say, if I see the figure 1, if I apply the sine rule, I can say n1 sin theta. So this light is coming, so I can apply n1 sin theta critical is equals to n2, and this becomes 90 degrees. So n2 sin 90. So from here I can write sin theta critical is equals to n2 by n1. So sin theta critical is equals to n2 by n1. Equation 1. Now if I apply the sine rule for the second case. I can see here, this is sine theta 1 is equals to n2 sine theta r. Now in this case sine theta is 90 minus theta 1. So if I apply this one, I can write n1 sine theta 1 is equals to n sine 90 minus theta 1, that is cos theta 1, so tan theta 1 is n2 by n1. Now it is given in the problem, so tan theta 1 I know, I have to find sine theta 1 because the ratio is given as sine theta critical divided by sine theta 1. Sine theta 1 I know, sine theta critical I know, but sine theta 1 I don't know. So what I will do, I will calculate sine theta 1 from this expression. So let us calculate. I can write something like this. So tan theta 1 is equals to n2 by n1. So this is n2 n1 theta 1. So this is n1 square minus n2 square. So this is plus n1 square plus n2 square ka root. And then I have to find sine theta 1. That is this height divided by hypotenuse. That is the n2 by n1 square plus n2 square. Now as given in the problem, if I apply sine theta critical by sine theta 1, that is n2 by n1, that is the sine theta 1, I can theta critical from here, that is n2 by n1. So n2 by n1 divided by, okay, so this is not gone, basically this is a mistake, n2 by n1, sine theta 1 is n2 by root over n1 square plus n2 square. This is given in the problem, that is eta. You write this one and then we will go further. So this eta is given basically. So this is given. Now you see, if you know eta, you can solve for n1 by n2. So what we can do is we can divide by n1 square on the top and by n1 by the bottom. We will have 1 plus n2 square by n1 square. So this is not eta, this is n2 by n1. Now if I square both sides, so this will come eta square is equals to 1 plus n2 square by n1 square, eta square. If I take 1 this side, eta square minus 1, that is n2 square, n2 by n1 whole square. Now if I take root, this becomes n2 by n1 is equals to root over eta square minus 1. n1 by n2 is simply, this is the massaging of equation. You can understand this is very fairly easy problem. Now you see, in this problem, you just take 1 minute and you do write and then we'll discuss. If you see in this problem, what we have learnt is, basically we can relate two types sine rule. So in one experiment I know sine theta r, in another experiment I know theta 1. I also know one relation, that is the angle between incident ray and angle between refracted ray is 90 degree. So I know the second equation. Now if I relate or if I assimilate all these informations, I am getting this n1 by n2, so refractive index of medium 1 with respect to refractive of other medium. If I somehow know the refractive index of one medium, I can always find the refractive index of the other medium. And this is the important point. So this problem, you see, in this case what will happen if I have n2 is equals to 1, eta is equals to 1, so this becomes infinite. n1 by n2 is so infinite. So how this is possible? This is practically not possible. This means eta 1 is not possible. So I cannot have sine theta critical. So eta 1 means sine theta critical is equals to sine theta 1. That is practically impossible. I cannot have a angle, and what point of time it says angle, so ray gets refracted by 90 degree angle. And in that case it says light ray goes something like this. Is not possible. If this angle is theta critical, then all the ray will get reflected back. So I cannot have that possibility. So and eta cannot be 1. That is mathematically also possible. From here I can see eta can't be plus 1. So we'll discuss the next problem. This is important problem.